come on in, sit down. We're going to get started. This is the start of the 8th annual Nebraska Wind and now Solar Conference.
Oh, okay. Yeah, my presentation today is going to be based on the UNL climate change report that was released in September of 2014. So since that time, we've been working with stakeholder groups around the state to look at the implications of climate change on their particular sectors. And so we've just concluded a series of 8 roundtables, but we've also been doing a lot of presentations around the state to various groups and conferences and workshops, sort of presenting the summary of the UNL climate change report for various audiences. So my presentation today is really going to focus on some of the results from that study and also some conversation about the roundtables that we've been holding.
And so Dr. Willhite, who is our speaker, is a very interesting fellow. I've worked with him quite a bit in the last several years, and as we communicate back and forth with emails and texts, I know that he doesn't hang around Nebraska a lot. So when we talk about bringing the speakers from the state and the national level to the WIND conference to let us know what's going on, he's en route, he's traveling. For example, he was in Switzerland in March of 2013 as a part of the National Drought Policy. He chaired that, so he's been in Latin America, he's been in Europe, he's been in Africa, he's been in North Africa, he's been in all of these different places around the globe, sharing his expertise as he has headed up the National Drought Mitigation Center and the International Drought Mitigation Center. It is my pleasure to present to you an expert on climate and weather, Dr. Willhite.
Thanks very much, John. Well, it's a pleasure to be here, and I appreciate the invitation to speak to this group. I was here for the presentation just earlier today, and I found that very interesting from the State Energy Office. So John gave you a bit of a background on the report that we did. The report was issued in September 2014, and it was a direct result of legislation that was passed by the legislature the previous year that called for the state of Nebraska to really look at the implications of climate change, do a review of the literature and see where we were and where we're going in terms of changing climate in the future. This process was one that we embarked on at the university after considerable discussion. So I want to commend my co-authors on this report, which were Deborah Bathke, Bob Oglesby, and Clint Rowe. So there were 4 faculty that have brought to the table, I think, different areas of expertise in terms of their understanding of the climate change issue, from the sort of physics of the atmosphere, looking at the implications of that, and so forth. One important part of the study, which I'll talk about in a few minutes, was what are the implications of the changes? You know, what changes have we seen? What changes are projected into the future? And then what are the implications of these changes for some of the key sectors for the state of Nebraska? And so we tried to address those in the climate change report itself, but we had limited time and limited resources to do that. But they were addressed through a series of commentaries that were included in the report. But then following that, as John mentioned, what we've been doing is, in the last month, we organized 8 one-day roundtable events focused on different sectors, with the idea that each of those sectors would bring together key stakeholders in those sectors to talk about, again, the implications of climate change for that sector. So tomorrow I'm meeting with the organizers of all 8 of those sectors, and we're going to be now pulling this together in terms of a final report. And that final report we hope at least to be available in draft form by December. So we're only about a month away from that. So we've been running at a very fast pace with this issue. The interest in this issue, the interest in the report has really been outstanding. And so we've received a lot of very positive feedback. So the title slide shows again the title for the report itself. If you haven't seen the report and you'd like to have a copy of it, hard copies are hard to find these days because the report is almost out of print. I have all the remaining copies, which probably totals about 20 or 25. I have been encouraging groups, because we continually get requests from various groups for 25 or 50 copies to pass out to members and that sort of thing. It's no problem for you to go to this website, download the PDF, and print it yourself if you want to do that for your clientele. Nebraska Extension Office just did that because they are planning a whole strategy now, action teams around climate resilience associated with this report. It's a spin-off of the report. So if you haven't seen the report, go take a look at it, download it, but if you need copies, don't come to me and ask for copies because I don't have them, but you're free to print your own copies based upon the download. Okay, so this is a list, if you can read that from your seats. This is a list of the 8 roundtables that we had. So we did 8 of these in a period of 4 weeks, so it was rather exhausting. John mentioned Ken Haar earlier. Ken actually attended, I think, 6 of the 8 roundtables around his schedule, because he's very interested in pursuing looking at more outcomes from the UNL climate change report and then engaging stakeholders in this discussion. So the very last roundtable that we had was actually focused on energy management and energy availability. And that one was actually held on October 22nd. And so that's the most recent. So the rest of, all of the organizers are in the process now of pulling together the discussions that went on during their particular roundtable. So when you talk about the issue of climate change, obviously it's been politicized greatly in this country, which is very distressing, because we really need to be focusing on the science of climate change and not focusing on the politics of it. And the United States is really, of all the countries of the world, the one that's the most unique in terms of this particular issue becoming so politicized between our 2 parties, the Democratic Party and the Republican Party. But if you look at some of the key questions that come up when you talk about climate change, there's first the question of, well, is the Earth's climate actually changing? Well, the evidence for a changing climate is just overwhelming. We see it everywhere. And so it's not just an increase in temperature, but all of the side effects of an increase in temperature that you see in terms of more frequent heat waves, more frequent droughts in different parts, or more severe droughts. All of those things, changes in precipitation patterns, distribution, the intensity of rainfall events, all of these things are being triggered by this increase in temperature that we're seeing globally, and for most places locally, an increase in temperature. The amount of change, the degree of change that different locations are seeing is going to vary from one location to another, because of the fact that each location on planet Earth, the climate is controlled by a series of climate controls. And these are more dominant in, some of these are more dominant in one region versus another region, and so on. Some are influenced by proximity to water, ocean currents, and so forth. So the degree of change is going to vary from one location to another. But what we're seeing globally, and looking at the trends of this, this is a change that is quite dramatic. The second question is, are humans and their actions the primary cause? And this is where a lot of people will say things like, well, the climates have always changed in the past, so this is just a natural phenomenon. Well, it's true that climates have changed in the past, but the drivers for this change are related to the increased concentration of greenhouse gases, changes in the Earth's land use patterns and so on, associated with changing reflectivity of the surface and so on, and some other factors as well. But the dominating factors are principally the changes in greenhouse gas concentrations in the atmosphere. So I'll talk about that in a few minutes. Finally, a question is, well, how do we respond to this? Do we do nothing? Do we just sit and let this happen? We're already adapting to the changes that we've already seen. So the changes are going to become more and more dramatic as this century unfolds. So adapting to this is one solution, but the other side of this is to what degree can we reduce the amount of warming that we're going to see into the future through the process of mitigation. And the process of mitigation is referring to reducing the emissions of greenhouse gases into the atmosphere in order to reduce the rate of warming that we're expecting. Globally, the science community says we really need to try and keep the amount of warming that we're going to see below 2 degrees centigrade. That is very much in jeopardy at the moment. Most of you are probably aware that there's a huge global climate conference. It's called COP21, Conference of the Parties 21, in which essentially all countries of the world are going to be getting together in Paris beginning on November 30th for about 2 weeks to try and come up with a global agreement on greenhouse gas emissions. So about 2/3 of the countries of the world have already submitted their proposals indicating their intent in terms of reducing greenhouse gas emissions from their particular countries. And so it's going to be interesting to see what happens in Paris, because many people think this is our last chance. If we can't come up with some global agreements, this is just going to go out of control. And so there's considerable pressure to move forward. So for this presentation, I've kind of organized my comments around some key messages that Tony Leiserowitz gave us. He presented a Herman lecture last March at the University of Nebraska in Lincoln. And I invited him to come in. He heads up the Climate Change Science Communication Program at Yale University. And they've done a lot of surveying of the public with regards to their views on climate change, and he's divided the American public into sort of 6 Americas. You may have seen some of this work. It's very interesting work he's been doing both in the US as well as globally. But when he presented his lecture, he presented one slide that talked about the 5 truths of climate change. And because this is such a complex issue, and it's one that confuses many, many people because they don't understand the science behind it, so they dismiss it. He decided to try and summarize these 5 truths into 10 words, which obviously is a bit of a challenge. So the first 2 words are it's real. And it's real, and let's talk about why we know it's real, how we know it's real, and so forth. Again, this comment from some that will say, well, the climates have always changed in the past, and therefore what's driving these changes today are really natural factors. Well, natural factors have affected our climate in the past, and they will affect our climate in the future. These kinds of changes, for the most part, occur over tens of thousands of years. These are very long-term, gradual changes that occur that take us into an ice age, out of an ice age, into a warm period, and so forth. And so things like the changes in the Earth's orbit, wobbling of the Earth on its axis, these are both factors that have driven, these are natural forces that have operated in the past and they'll continue to operate in the future in terms of how they affect the climate on planet Earth. Also, the energy output from the sun. This varies on shorter time scales. It also varies on longer time scales. So this has had an influence in the past, and it will have an influence in the future. Things like volcanic eruptions, particularly large-scale volcanic eruptions, multiple large-scale volcanic eruptions, they put a lot of aerosols and other chemicals, dust, and so forth into the atmosphere. And these ingredients in the atmosphere reflect more energy back into space, and therefore you have a cooling effect associated with that. But this kind of cooling associated with volcanic eruptions is a short-term effect. If you think back, most of you can probably remember the eruption of Mount Pinatubo, which erupted in 1991 in the Philippines. And so if you look at the trend of global mean temperature that we've observed, you'll see that for a period of 12 to 18 months, global mean temperature actually dropped because of all the debris and chemicals that Pinatubo put into the atmosphere and then were distributed globally by wind patterns. But after about 12 to 18 months, these disappear, and once again, global mean temperature, even though it dropped off a little bit, it resumed that trend, that upward trend that we've been seeing. So these are all natural forces. They don't have anything to do with humans and so forth. So one example, here you see in this slide a plot of sort of a smoothing trend for global mean temperature shown by the red line. And so for those that would argue that the reason we're seeing an increase in global temperature is because we're getting more energy from the sun. In reality, the blue line at the bottom shows the trend, the pattern of solar energy received from the sun. And you can see after about 1960, the amount of energy we've been receiving from the sun has actually decreased. So while global mean temperature has continued to increase. So this is not an explanation for global mean temperature increases that we've observed globally as well as for most locations on Earth. So then you have what are referred to as anthropogenic or human factors that are forcing changes in our climate. And so the one you hear the most about are the greenhouse gas concentrations in the atmosphere, and I'll talk about that a bit more in a few minutes. But the increasing concentrations of greenhouse gases, and the one you hear the most about, of course, is carbon dioxide that results from the burning of fossil fuels. But you also have methane, nitrous oxide. These are other greenhouse gases that are important in terms of the Earth's heat balance. And so I'll speak to that in a minute. Changes in aerosol particles because of burning of biomass, forest fires, rangeland fires. You see that on the right-hand side there in the middle, this pattern, the flashes of fires and so forth. The lower right-hand corner shows smoke plumes associated with the 2012 drought in the U.S. and all of the burning of forests and rangeland, grasslands and so on, particularly in the western United States, but also in the Great Plains region. And then you have the changes in land use, and we've changed almost the entire surface of the Earth in one way or another. Wherever humans are occupying Earth, we've changed the reflectivity or the albedo of the Earth's surface. So these are all anthropogenic changes that have occurred. These are occurring over shorter time scales, over periods since, you just think of the expanding world population. We're now up to over 7 billion people. By the middle of this century, we're expected to reach 9.6 billion people. We are modifying the Earth, we're modifying the atmosphere, and this is critical. So if we look at this trend of global land and ocean temperature anomalies, so these are departures from the average, you can see the warming that's occurred since about the mid-1970s, around 1980 and so on, and it's been a constant increase. And in fact, September of this year is the warmest September ever recorded in the historical record. And it seems like we just continue to break that record globally. It obviously varies locally, but globally this is what's happening. So the second truth is it's us. So again, reflecting back on these anthropogenic forcings that are occurring within our climate. So we have to look at the composition of the Earth's atmosphere. And you all know that the atmosphere is made up primarily of nitrogen and oxygen that comprises essentially 99%. Then we have this small percentage, 1%, which are the greenhouse gases or these trace gases in the atmosphere. And so to an average person, you might say, how can this 1% be so critical in terms of the heat balance of the Earth, the climate of the Earth? Well, the reality is without these greenhouse gases, the Earth's temperature would be 57 degrees cooler than it is today. These greenhouse gases are the gases that trap the heat in the atmosphere. They form a blanket, and this is what makes planet Earth livable. And so these greenhouse gases have controlled this climate of the Earth historically, and changes in the concentration of these in the atmosphere changes the potential for a changing heat balance and therefore changing climate. So if we look at CO2 concentrations over the last 800,000 years, you can see there's a line drawn across there, pre-industrial CO2 on the left-hand side. And over the last 800,000 years, CO2 concentrations in the atmosphere have rarely exceeded 280 parts per million. In 2013, we surpassed 400 parts per million. Today, we're at about 413. We're increasing by about 2 parts per million per year. And so the projections are we're going to go to 450, 500, 550, 600. This is just going to keep going as long as we continue to burn fossil fuels at the rate we're doing it today. So changes in our behavior in terms of what we're doing in terms of burning fossil fuels can lower the projections for the future. So the Earth's energy balance, and I'm assuming that most of you are somewhat familiar with sort of the way this system works, but the way the system works is we receive almost all of our energy from the sun, and the energy from the sun comes to us in the form of short-wave radiation, solar radiation. The Earth's atmosphere is transparent. This is what we refer to as the greenhouse effect. The Earth's atmosphere is transparent to this short-wave solar energy. It passes through the atmosphere. When it reaches the Earth's surface, it's absorbed and it's re-radiated as long-wave infrared radiation. The atmosphere is not transparent to long-wave infrared radiation because these greenhouse gases actually absorb it, and so it's trapped. So if we have a situation where incoming solar energy is equal to outgoing infrared energy, then we have a relatively stable Earth heat balance. Obviously it varies from year to year and so forth. But if we change the concentration of greenhouse gases in the atmosphere, then what we're doing is we're altering this balance. We're putting an extra layer, an extra blanket over the Earth to retain more heat, and the result of that is an increase in temperature. And with an increase in temperature of the atmosphere, you see an increase in temperature of the ocean, sea surface temperatures, the amount of water vapor in the atmosphere, because the more heat you have in the atmosphere, the more energy you have, the more evaporation that's occurring. You have melting of glaciers and so forth. So all of these things are the result of this changing heat balance for the Earth. So if you look at the average global annual temperature, this goes back to 1880, you can see the variation around that red trend line. But again, look at the trend. The trend is upward, obviously. And the variation around that trend line is due to interannual variations in terms of the weather patterns. Occurrences like El Nino that you've been hearing about a lot recently, because there's a huge El Nino that is formed in the Pacific Ocean. It's going to have significant impacts on climates all around the world this coming winter and into the spring, and maybe longer. You have La Nina events, you have the North Atlantic Oscillation, you have a lot of things like this that are occurring on different time scales, and that causes that variation that you see from year to year. So, in just a minute I'm going to have our IT guy trigger this animation. So this animation puts that last slide into a spatial context. So what you see on the screen, the areas, this is showing global temperatures from 1884 to 2012. And so what you see on the screen, this is in 1884, the areas in blue are the areas that are anomalously cool, so cooler than the long-term average. So what you're looking at here are global mean temperatures for a given year in terms of how they depart from the long-term average. The areas in yellow and brown are those areas that are above the average. The areas in blue are the areas below the average. And in the center there, just next to the legend, you see 1884. So as we animate this, you will see it move from 1884 all the way through 2012. And so you'll see how the variation from year to year changes, but you'll also be able to see the trend in terms of the spatial pattern of global mean temperature. So if you can try to trigger that in the back. So here you see that annual variation in terms of areas that are warm, areas that are cool, compared to the long-term average. So now we're up to 1925. You'll see in the 1930s, you see that big red area over the United States representing the Dust Bowl, the huge drought that we had for that during that decade. So again, the variation from year to year that you saw in that trend line, but look what happens when you get to about 1970 in terms of the spatial pattern of above versus below temperatures. Okay, so this again puts this in a spatial context rather than on a graph showing a line. And you can see how some areas have warmed more than others over time or in individual years and so forth. Okay, so the next truth is it's bad. So one thing, there's a lot of different ways you can express this, and I really don't want this to be a gloom and doom thing, but it is bad. And so for those people that continue to deny the science as well as the observations of what we're seeing is really putting, in the words of a number of people that attended our roundtables, planet Earth in jeopardy. And so it's important that we do something about this. What this slide is showing is the global temperature change by decade. And so you can see from beginning in the 1950s, 60s up through the 2000s, how if you average global temperatures by decade, each decade is exceeding previous decades and by a considerable margin. A rather remarkable statistic is that if you look at the changes in, or the observed monthly average temperatures, and you compare those to a long-term average, we've had 369 consecutive months in which that month exceeded the long-term average. And October is going to make it 370. And so what a string of warmer temperatures we've been seeing globally. People get confused by expressions of weather versus climate. Weather is the condition of the atmosphere at a particular place and time, and it's through observations of whether it's sunny, what the temperature is, what the wind's doing, wind speed, and so forth, the direction of the wind, cloud cover, and these kinds of things. They get confused by weather, what is happening over a short time frame, versus climate, which is the composite of weather over a longer period of time, so it represents a trend. These are two very different things. So when people say, well, global warming must be a hoax because in August we had very cool temperatures where I live in Nebraska. You have to look at this from a global context, and you have to look at it in over a long-term period or a trend. So as part of the climate change report, I invited a number of colleagues both at the university and state agencies and in the private sector, groups like the Nature Conservancy and so on, to reflect on the implications of climate change for their particular sector. Whether it was ecosystems, whether it was energy, whether it was water, whether it was agriculture, urban systems, rural systems, and so forth. And so these experts in their field looked at the changes that we've seen to date looked at the projections for the future, and then interpreted those changes as we move forward in terms of how this was going to affect their sector in the state of Nebraska. So, what are those projections? Well, if you look at temperature, and the information that I'm going to give you is projected for, this is the last quarter of this century. So we think, well, that's a long ways away. Well, it's 2015, and it seems like just yesterday we were concerned about our computers crashing when we entered the new millennium. And so already 15 years have passed. 2050 is going to be here before we know it. I probably won't see it, but hopefully many of you will. But this is a change that's really going to occur more and more rapidly, become more dramatic as we move to the future. So if we look at changing temperatures in Nebraska, the projections are that by the fourth quarter of this century, so by 2070, 2075, towards the end of the century, that we're going to see a range of changes from about 4.5 degrees Fahrenheit to 8 to 9 degrees Fahrenheit. Now, the reason for the difference between 4 to 5 versus 8 to 9 is not because the models that are doing these projections are so poor. It's because we don't know what the future behavior of the people that live on planet Earth is going to be with regards to the burning of fossil fuels. So, to what degree are we going to be able to lower the trajectory that we're on in terms of adding more CO2 and other greenhouse gases to the atmosphere? So if we're on the business as usual path, which is like we are on today, we're going to be at 8 to 9 degrees according to the computer projections. And these computer models, you can question, I mean, there are obviously uncertainties within these computer models that are trying within a computer program to represent the physics of the atmosphere and its interactions with the land surface, the ocean surface, the ice surface, and so on. But if you run these models over the historical climate, you can actually reproduce the climate that we've seen over the last, say, 125 or 50 years. So it gives us confidence that we can run these models into the future, and we can play around with the different concentrations of greenhouse gases as we move into the future based on different scenarios of human behavior. And we can say, okay, well, this scenario is going to take us to one point, but if we follow a different scenario, it's going to take us to a different point. And so these models are actually pretty good at telling us what's going to happen with regards to temperatures as we move to the future. So the 4 to 5 degree temperature range is based upon a lower emission scenario. It's probably an unrealistic scenario because to get there is going to would have to result in tremendous changes very, very rapidly in terms of greenhouse gas. So the more probable future is 8 to 9 degrees. And remember also, because before we released our report, we had a conference call with our congressional delegation. And one of the questions from a representative from one of our representatives in Washington was, what if you're wrong? Our response was, you have to remember that this projection of 8 to 9 degrees has arrow bars on either side of it. So yes, it may be wrong, but the assumption that we're going to be wrong and it's not going to be that bad is fallacious. We could be very wrong because we don't understand some of the tipping points in concentration of greenhouse gases on the other side. So it could be much worse. So you can't assume that we're going to be wrong and it's going to be wrong in the direction of being more positive for us. Another issue with regards to projected changes is the number of high temperature stress days is expected to increase dramatically. The low emission scenario, between 13 and 16 additional days, between 22 and 25 additional days over 100 degrees by the last quarter of this century. Number of warm nights. Most of the warming that we've seen in Nebraska so far has been in higher minimum temperatures during the winter. But we're also seeing that during the summertime. And this is going to become more pronounced as we move into the future. The frost-free season for Nebraska has already increased by an average of 2 weeks in the state. It varies between about 1 week and 3 weeks, depending on what portion of the state you happen to live in. But this is projected to increase by an additional 2 weeks by the last quarter of this century. As a result of the higher temperatures and more variable precipitation, coming in the form of these high-intensity rainfall events, which is something we've observed dramatic changes in over the last 30 years or so, not only in Nebraska, but particularly in the Midwest, into the eastern United States and the Southeast. This has been pretty dramatic. So as a result of this, we expect soil moisture to decrease. Flood magnitudes, we've seen an increase in flood magnitudes, and this is because this is a national trend, but we've certainly seen that in the Midwest and the eastern portions of Nebraska associated with more high-intensity rainfall events. It doesn't mean we're getting more rainfall total for the year necessarily. What it means is that more of our rain is coming in high-intensity rainfall events, and the reason for this is because you've got more energy in the atmosphere, more water vapor in the atmosphere, and the result of that is more intensive rainstorms. We've certainly had that in Lincoln over the last year or so. A big concern also is snow cover. There's a longer-term trend for decreasing snowpack in the western United States. This has been very pronounced in the Southwest, but it's also occurring in most other areas of the western United States. Why is that important for us? Because it's going to change surface water flow across Nebraska. We're seeing less accumulation of snowpack in the Rockies. It accumulates later in the fall because of warmer temperatures. It melts off earlier in the spring, changing the hydrology of river basins. A lot of the snow, because of warmer temperatures, is actually evaporating into the atmosphere and never enters the hydrologic system. So a lot of concerns about that and flow on the Missouri River and the Platte River system as we move forward. Here you see two maps, one with the lower emissions scenario, one with a higher emissions scenario. Again, the 4 to 5 degree range is the low emission scenario, the 8 to 9 degree range, the high emission scenario. Projected increase in the number of days over 100 degrees. What this is showing is a series of bar graphs for different regions. And so you have different time periods as you move from left to right on those particular graphs. The regions that appear to will be the greatest losers in terms of the number of high intensity or high temperature stress days seem to be the Great Plains, the Southwest, and the Southeastern United States. And so the reason for the different color bars, these are the low emission scenario versus the high emission scenario. And so under the high emission scenario, this is the business as usual, which is kind of that's the path we're on at the moment. So if you think about the drought that we had recently in 2012, which was a very unusual and very intense drought. It was unusual in the sense that it came on very, very quickly, and it was a combination of both very dry conditions, which provided feedback, which allowed the number of high temperature stress days to increase dramatically. So in 2012, we had 2/3 of the United States that were in different severity levels in terms of drought. This map, as you probably know, is produced weekly at the National Drought Mitigation Center at UNL. And so if you look at the number of high temperature stress days that occurred between June 1st and September 15th in 2012, you can see the pattern there, but you can't read the numbers, so I've pulled out a few numbers for you. For McCook had 37 days over 100 degrees in the period from June 1 through September 15th. Lincoln had 17 days. In the lower left-hand corner, you see the average. McCook averages about 11 days. And again, they had 37 days in 2012, during the summer of 2012. And Lincoln averages about 5, and they had 17. So if you take the projections in terms of high temperature stress days into the future, the projections are that 2012, by the last quarter of this century, could be a relatively average year. So this gets pretty scary from the perspective of energy, whether it's wind, solar, whatever form of energy, demand for water resources, health implications, and so forth. So, as an example of one of the implications of this for Nebraska in 2012, this map shows groundwater levels, declines in groundwater levels or changes in groundwater levels between the spring of 2012, beginning before the drought, through the spring of 2013. And so you can see for most of eastern Nebraska and parts of southwestern Nebraska, you had declines of anywhere from 5 to 20 feet in the groundwater level for a one-year drought. So droughts oftentimes come in multiple years. California is currently in their 5th consecutive year. The southern plains and the southwest just went through a 7 to 8 consecutive years of drought. Some of those areas are still in drought. So if you impose a series of drought years like we had in the 30s or the 50s or even 76, 77, back-to-back drought years, the implications of that on groundwater resources are dramatic in this state. We have a good system, I think, with natural resource districts to try and control this in terms of the extraction of groundwater, but the implications of this for agriculture and natural resources, water resources for the state are significant. So the next two words were scientists agree, and you may be familiar with the fact that there have been a series of surveys of the peer-reviewed scientific literature about climate change. And the numbers, regardless of who's doing the review and what country scientists are doing the review, when they look globally at literature, it's 97% of climate scientists agree. So it's a question here, when you say climate, or when you say scientists agree, it's a question of consensus. So the consensus within the climate science community is that not only is the climate changing, but that humans are the dominant cause. And if you look at the reports that come out of the United Nations, the World Meteorological Organization, and the Global Environment Program and so on, this is the Intergovernmental Panel on Climate Change reports. There you have more than 1,000 scientists that do a review about every 6 years or so. And they conclude, with very little uncertainty, that humans are the driving cause here. So the science community does agree. And there was recently another study done that actually showed out of 24,000 peer-reviewed publications, there were only 4 that the scientists were actually denying this consensus on climate change and humans being the primary factor. So the final 2 words that Tony gave us was that there's hope. But the hope is based upon action, and whether we're going to do something about this or we're going to just let this move forward into future decades and we continue to burn fossil fuels at the rate that we're currently burning them. So the Pope obviously this summer in July issued an encyclical on the environment, and one important piece of that was on the issue of climate change. And the way he was expressing it, and the way I think a lot of us tend to want to consider this, that climate change is really a moral issue, because you're talking about the implications for future generations. You're talking about the implications for those people that have the least amount of resources to deal with the changes that we're going to see in the future and that we're already seeing. So these are the people, the vulnerable people in cities around the United States, the more poverty-stricken individuals, the developing countries of the world. You know, the United States and other developed countries of the world have created this problem. And it's getting worse because other developing countries like China and India and so on are expanding their burning of fossil fuels. So we need to get a handle on this. So it does become a moral issue for the future. So it's really time to move, beyond the emotions and the politics associated with this, and denying that this even exists when all of the data demonstrates that it is occurring and it's occurring dramatically, and that human actions are the cause. And really look for solutions and look at the science behind this and try to understand the science. And there's a lot of communicating of that information that we need to do to the public. So to conclude, in terms of these projected changes, I'm not going to review the ones that I've talked about, but obviously the consequences that we're going to see from the projected changes in climate that I just talked to you about is going to depend upon the resilience of a particular sector. So every sector has a different level of capability to adapt. The sooner we adapt, the better. The more we can do to lower greenhouse gas emissions and therefore reduce the amount of warming through mitigation actions, the better we're going to be. And so all of these things are important as we move to the future. The outcomes of these climate change roundtables, I think, are going to be very instructive to groups throughout the state that are very much on top of this issue and are trying to move the conversation forward. John mentioned a few minutes ago the Nebraska rural poll that came out recently, in which 61% of rural Nebraskans supported, either strongly agreed or agreed that the state needs to have a climate action plan. We're currently working to provide information to Senator Harr. Senator Ken Harr intends to introduce legislation in the legislature in January to move this state towards a state climate action plan. There are about 20 or 25 states that have these plans in place. Many, many local communities around the country have these plans in place. And I think Nebraska, considering the fragile nature of our ecosystem and our climate, the gradient that we see from east to west as well as north to south, but primarily east to west, the importance of agriculture and irrigated agriculture in this state, we really need to get a handle on this and work towards, what are we going to do as a state, but also as part of a larger group, both nationally and globally, what are we going to do for the future. So I appreciate your attention, and if we have some time, I'll be glad to take questions. Thank you.
Nation, has there been any real analysis of that, to how that actually translates into actual global temperature change?
What I might, because I'm not an expert on that sort of energy aspect of it, but the roundtable that we had on October 22nd, we had a gentleman there, Steve Rose, who was with the Energy Power Research Institute, and he gave a great presentation looking at all the different components of the energy sector and the shifts that need to take place and so on. So if you want to go to the website for those roundtables, it's an easy one to remember, so let me tell you all what that is. It's just go.unl.edu, so if you see the URL is at the bottom of this page. So if you go to that website, you'll not only see our climate change report, but you'll also see information on each of those 8 sectors. And so if you go to the one on energy, we've actually uploaded his presentation, so not only do you get the video of his presentation, but you also have his slides that are there in PDF format. So take a look at those, and if you have questions about some of those things, I would email Steve Rhodes with IMPRI, because I think he could be of help. So I see a stop sign in the...
When you get outside, your circle with the scientists and that, and being a meteorologist myself, I get questions from family and neighbors, etc. Do you think this global warming is real? And I think a lot of those questions are driven by what you said earlier about, it's driven by politics, and they hear politicians on the radio or on national news saying, debating whether it really is occurring. And I know it's a broad question, but I'm just curious your opinion. Why do you think that is? Why is it such a political, hot topic, and why is there so much misinformation coming from that side?
Yeah, one is the media itself. Not all media, but in talking to my journalist friends, they tell me one of the problems with an issue like this is that journalists are trained to present both sides of an issue. But when you have a consensus on an issue like we have on climate change within the science community, And then you, for the local newspaper, you publish an article that maybe is an AP article or something that you've taken from a workshop. And then it's strongly supporting the scientific consensus, but then they'll stick in a comment from a denier. And it just confuses the public. That is the issue. So that's a problem. You have to realize that a lot of the misinformation that is out there about climate change is being driven by the petroleum industry, the fossil fuel industry. I don't know how many of you have seen the movie Merchants of Doubt. If you haven't seen it, it's on Netflix. And what the movie is about is how the lobbyists were used by the cigarette tobacco industry back in the day when they were trying to convince the American public that smoking was not harmful to your health and didn't cause cancer. And so they put out this huge misinformation campaign to debunk that idea. Those same people, those same firms are being used by the oil industry, the petroleum industry, to not only discredit scientists, but to discredit the science itself. And that movie, Merchants of Doubt, exposes all of that. It's a documentary. I think you'd really enjoy looking at that. Because, I mean, they think it's funny that they discredit a scientist based upon, again, misinformation. So it is, you know, and also in response to your question, climate change is an incredibly complex issue in terms of understanding what's happening out there. And most people just don't have the science background. So it's easier to ignore it than it is to maybe get into it. And we tried with our climate change report to present this not as a science document in the sense that it would be a peer-reviewed type document. We've tried to present it in a form that I think most everyone can read and probably understand. And we really tried to focus on those issues that were most important to Nebraska, where we live. We didn't spend a lot of time talking about sea level rise, for example. It's not an issue here, but it's a huge issue globally, and it potentially is a huge issue in Nebraska, because as those coastal areas get flooded, where are those people going to go? They're going to move to the interior, and so immigration issues associated with climate change, we're already seeing it in Europe right now as a result of what's happened in the Mideast. But we're going to see it here. It's going to be on our shorelines as well. So environmental refugees are going to be the norm rather than the exception in the future. So thanks again for your time.
And thank you very much, and thank you for your kind attention. And now we're going to break, but we're going to come back here in 10 minutes, and they're going to serve food. So note to self, try to kind of clean up your table area a little bit, maybe leave your stuff on your chair, but they're going to be serving us, and you also might want to look at where some of the tables are, and you might want to acquire some new friends and acquaintances while you eat, while we come together, and they will be serving us. And so with that, let's break, and we'll see you back here in 10 minutes. Thank you much.